Hello guys, and welcome back to the ongoing saga that is my EV conversion. And as you can see, quite a lot has changed from the last video that I put out. However, this is not what I need to talk to you about, because unfortunately I seem to have lost a lot of footage. This video is going to be a little bit disjointed, unfortunately, but I'll take you through some of the trials and tribulations I had trying to connect the high voltage battery, which was sitting about here somewhere, to the DC to DC converter stroke high voltage junction box, or PDM, power distribution module, from the Nissan Leaf. A few bits and pieces, some of which are no longer relevant anyway, but I'll take you through what happened. And unfortunately, the exciting bit where I managed to get the Nissan Leaf BMS to talk to my mobile phone, I thought I had footage of it and I cannot find it, so you'll have to take my word for it. We managed to get the BMS working and talking to LeafSpy on the phone. So we will go back a few months to what was happening here in the garage before I tidied it up. Alright guys, well, I'm in the process of trying to set up a temporary connection just to do some testing, and to do that what I've got is this Heath Robinson situation in front of you. Basically what we've got here is we have not yet connected up, by the way, so it's not live, but 350 volts coming out of here going into this junction box, and that provides a permanent connection through the resistor to this side, which then goes to feed the positive side of the Nissan Leaf connector. So basically, as soon as I fit this fuse connection across here, that will provide 350 volts. Well, actually there's another connection down there to be done. There's a couple of connections are off, but the final connection will be this one, and when I make that connection, it will then send 350 volts down through here, through this resistor, and straight into the Nissan Leaf connector. And that, like I say, will be coming through this resistor, so that should hopefully prevent any issues with damaging the inverter or the DC to DC converter. So whenever I then decide that I want to do some proper testing, I have this. It's just a standard kettle type lead coming out of here, which will then plug into this one. So what I want to make it live, I just plug these two together, and that will provide the main current flow. Now, for testing purposes, there won't be very much current, so I'm not terribly concerned about heavy duty wiring and so on. The whole thing is wired with this lighter duty wiring. So for testing purposes, this should be okay. But like I said, I have a 10 or 15 amp fuse in here anyway. 10 amps at 350 volts is 3.5 kilowatts. That's still a fair thump, but that's basically there to stop me burning the place down. And then this hopefully will be sufficient just to get the voltage going into the DC distribution board, which then can feed into the inverter and the charger and all the other bits and pieces that are lying on the floor. So what I'll do is do a bit of tidying up, get this all wrapped up in plastic so that I can't light myself up on it, and then we'll take it from there. Okay guys, well, the first attempt was a complete and utter failure. This resistor seems to have blown. Now, I'm not sure if it's because the voltage was already across the resistor and into this connector before I connected up plug these two together. I don't know. I'm not sure. I'm going to try it again. But basically, this resistor just died. It's a 50 ohm 100 watt, and it's now open circuit, so I'll stick it in the you-know-what bucket and pull out my 30 ohm one, which should be okay. It is the right sort of size. It may be just this is the wrong kind of resistor. It doesn't handle surge very well. I'm not sure. I'll try this one. If it doesn't work, then it's back to the drawing board. Guys, I've just realized I have made a huge mistake, and one which could have cost a lot. I think I've caught it in time though, thankfully, and thanks to guys on Open Inverter, I've caught on what I've done wrong. I plugged it in earth about face. I put the pause on the neg and the neg on the pause. That's why I was melting my resistors, pre-charge resistors, and thankfully they melted before anything else did. I do have a 10 amp fuse in this, but that 10 amp fuse, yeah, that's a lot of current, and that could have done serious harm to this. This is the DC to DC converter stroke high voltage junction box, and it's the bit that sends the power out to the battery to charge a 12 volt battery, connects the charger. Doesn't actually send anything out to the charger sends voltage through it, but anyway, it connects the charger, connects the inverter, it's upside down, and also the air conditioning compressor, and somewhere over there was yeah, heater block. That's for the HVAC heater, heating, ventilation, and well, whatever, it's the heater. So anyway, hopefully this is okay. I think it should be. I did pop several 100 watt resistors, but I don't care about that. I've got a few more coming, so that should be okay. I don't have the original junction box that was inside the Nissan Leaf battery pack. If I had it, I probably would have realized what I was doing wrong, but basically I watched a video where a guy was showing the connector block, and he was saying that the pause and neg was on this end, and that was fine. Unfortunately, I didn't watch it closely enough and carefully enough to realize that he was talking about the battery connection end and not the end that goes to the to this unit. So yeah, I got it wrong. Right guys, don't mind admitting that I'm a little bit nervous about this. I believe I have now resolved the issue of reverse polarity on my pause neg, which was causing my previous pre-charge resistors to pop. So I think I've got that resolved, and now, and now we're going to give this another go. Like I say, I'm a little bit nervous about this. I've been kind of putting it off for several days, various reasons of personal issues as well at home with family loss. So I'm now back to it. I'm going to give it another go and we'll see what happens. Okay, well, nothing bad happened. Nothing went pop. Nothing actually happened at all. So before I try and connect in the direct current, I'm going to, or the direct connection, I'm going to check that we're getting the appropriate voltage. I know you can't see this multimeter, you'll have to take my word for it. I'll try. But here we get 350 volts. Here we have 350 volts. And here. And here. Yay! It didn't pop the resistor this time. Okay, so we've got 350 volts is going to our unit over here. Now I can make the direct connection by plugging this in, and I can unplug the resistor. So we now have 350 volts going from the battery pack into this unit here. And we'll just double check what we're getting here as well. And that is showing up as 350 volts, something like that. 354. Brilliant. Right, so we resolved the issue that was blowing the pre-charge resistors. It was, yeah, I had the polarity reversed. Let's check the voltage on our battery pack, just out of curiosity, to see if it is charging or not. It was at 12 volts, it's now sitting at 12 volts, it hasn't changed any. So that's not charging as yet. I didn't really expect it would. I think probably we need a few things to happen for that to work. This may need to be shorted out, I'm not sure. I need to double check all that, but at least we've got this far and it didn't go bang, so that's a major bonus. Hello guys, and welcome back. And as you can see, we have a right mess of wires and cables sitting around here, but we're making slow progress trying to work out how to get all these different bits and pieces to work together. So what I'm going to talk about today is mostly this box and how it charges the battery. Inside there is a DC to DC controller, which is basically your 12 volt battery charger, plus the relays and bits and pieces to send power out to various high voltage areas of the car. What I'll do is I'll put the meter onto, yeah, put the wires on there so we can see what the voltage is. Okay, and as you can see, the voltage of the meter is sitting at 12.7, or the voltage of the battery is sitting at 12.7 volts. So there are two wires, or there's two plugs coming out of the power distribution module, PDM. That one we don't need just yet, I might need that later. This one is the one we're looking at, and pin number 3, which is I think it's the pink, I think it's that orange one, pin number 3 just there. The orange pin is the one we're thinking about. Now this is a random plug I've plugged into it, and so pin 3 and this one is pink. So I have pin 3 going to a cable. I have the negative of this battery going into just attached to the chassis. So what should happen is if I apply this, basically putting 12 volts onto pin 3, that voltage should go up. Now let's see if we can show me connecting it and at the same time show the voltage. Okay, there it goes. There we go, 14.15 volts. Now I've noticed that the DC to DC converter is making a bit of a squealing noise. I'm not sure if you can hear that or not, but that's causing me a little concern. I'm not sure if that's a problem or not. So we're not going to keep that on any longer, and there you can see the voltage dropping down. You can actually control the voltage that goes to the battery by putting a PWM signal onto pin 1, which would be the yellow wire. If you put, I can't remember what the voltage is or what, it's an 8 hertz I think it is. It's some sort of there's a signal you can put onto the pin 1 anyway, so you can, according to the duty cycle of the PWM signal, you can either make it, I think, from as low as 13 volts to as high as 15 volts, something like that. But by default it just kicks out 14 volts without any other input. Yeah, that's one more small step forward, and like I say, we are actually seeing CAN messages from the BMS, so I'm hoping to be able to read those CAN messages at some stage and put that into a format where I can see the voltage of each of the cells, and maybe even kick off the BMS and get it balancing the pack. That would be nice. Hi guys, this is just a quick update on the current situation with trying to get this battery pack to talk nice to the Nissan Leaf electronics. Where we're at right now is I think we've gone as far as we can go without injecting some CAN messages into it. And what I mean by that is I finally managed to get a hold of one of these things, which is the DC junction box or battery junction box that goes inside the Nissan Leaf battery pack. So what we've got inside here is we have the two contactors, we have a current sensor, connection to the, I'll just take this out of the way, no I can't, connection to the BMS, which is under this. So the connection to the BMS, the main connections to the DC to DC converter and high voltage junction box, and these are the main battery connections coming in from the battery pack. So this thing is doing what I wanted to do. I'll show you that in a second. I'll put that back on again just for safety's sake. So what we have is we have the main DC from the battery pack coming into here. This is the wiring loom from the inside the battery pack, and these are temperature sensors, and I think there's another temperature sensor around the corner. There was supposed to be a third one, but I didn't have it, so I've just put a 5k resistor in. I think it's 5k, something like that, just to try and bluff it that it's at the right temperature. This is the connection block that would have been on the outside of the battery pack. Basically, as going, that's feeding. These are CAN wires. These are positive wires. There's quite a few positive wires. There's one that goes through to an ignition switch, and I'm just using this light switch for that. The reason I've got the bulb here is I connected that in series with everything, so that the positive comes from the battery, the 12 volt battery, goes through that bulb, and if I have shorted something out, that bulb will come on, and hopefully things won't go bang and won't go up in a puff of smoke, but the bulb would come on instead. So the bulb isn't coming on, so I'm assuming everything is connected correctly. The battery is connected to the DC to DC converter. So, and the laptop is connected with, let me just reach over. Laptop is connected and should hopefully show some CAN. As soon as which is coming through on this Arduino, as soon as I turn it on, turn the system on. So what I'm going to do now is to flick this switch. This switch will take 12 volts from the battery, we'll put it through the bulb, through all of this stuff here, and it will activate this timer relay. The timer relay will, when the 12 volts comes through, the 12 volts goes to the common side, or the normally closed side of the, or is it normally open? I can't remember. It goes to one of the sides of that unit for about 2 seconds, which puts 12 volts to the contactor, which has the pre-charge relay on it, pre-charge resistor on it, sorry. And then it flicks over, and the 12 volts then goes to the two contactors, which then send the DC, or the 350 volts DC directly to the DC to DC converter. So basically it triggers the 350 volts to go through the pre-charge resistor first, and then it flicks over to the main contactors. So what happens if I flick that switch? As you can see, the battery voltage is about 12.8, 12.9. So if I flick that switch, if you listen here, okay, the first click was the contactor for the pre-charge resistor, and the second click was the two main contactors going. As you can see, that's now active and driving these two contactors. And up here, I'll probably have to reconnect this. We should be getting CAN coming through there. We were a minute ago. Yep, there we go. There's CAN coming through. Now, if I flick this ignition on, we should get, I'll just zoom in and focus. If I flick that switch, that puts 12 volts through to the BMS, and I think it did something. I'm not sure, I can't remember now. I think it did something. I think I checked and saw that it did something before. So anyway, that's now, oh yes, and you can see we're now getting 14.1213 volts. So the DC to DC converter is working. Now, unfortunately, if I plug in the charger at this stage, I'll give it a try. I was kind of hoping that if I got everything connected, it would work, but no. We've just got power. It's just saying ready, but it's not actually providing power to charge the battery pack. Guys, I'm going to butt in here and admit to having just cocked up and destroyed one of the contactors in my junction box. If you've been listening, you'll realise, and you understand what I'm trying to achieve here, you'll realise that I made a pretty fundamental error. I used the timer over here to turn on the pre-charge resistor, which puts 30 ohms across the junction box on the positive side, but I failed to think about turning on the negative contactor at the same time, which meant that the pre-charge contactor was turned on. We had positive going to the rest of the kit here, but we did not have the negative going to the rest of the kit, which basically meant that it did nothing. Then what happened was it flicked off, and the two contactors, the two main contactors, then flicked on and managed to weld one of them completely closed circuit. So trashed one of my contactors, I'm afraid. So what I had to do was to dig out of, I happen to have a more modern Nissan Leaf junction box, which I actually bought by mistake, but I took one of the contactors out of it and put it in instead. Now this one is a slightly different model number, as I'm sure you can see there, and there's the original. Slightly different model number, slightly different shape, but with a little bit of modification we managed to make it fit, and the connection is good, so it's the same connector, so all seems to be working perfectly at the minute. So what I've done is, instead of using a single timer over here, I now have two timers. And what happens is, when I turn on the power, the 12 volts to the first 12 volts to these two timers, what happens is that the 12 volts for the negative side of the contactor comes on immediately, and that's that one. So that comes on immediately. I turn on the 12 volts. The pre-charge also comes on immediately because it is connected to, if you look in there, pre-charge, it is connected to the normally closed side of the relay. So what happens is, as soon as I put on the 12 volts, both the pre-charge and the negative contactors come on immediately. Then if a second or so later, this relay kicks in, which puts on main relay 1, which turns on the main contactor here, and about a second later then this relay flicks on and turns off the pre-charge relay. What we'll do is we'll turn it on and show you that happening. Hopefully this you'll be able to see the meter showing. I'll try and zoom out so you can see everything. Okay, that's 30 ohms, should be 0 ohms, and oh, hang on a second, I didn't actually catch that. Turn it off again and try it again. It should. The timing on these things is a bit wonky and I'm not 100% confident about them, but for now we're going to go with it. Okay, right, I've turned this one, the timer on this one up, because that's the one that is turning off the pre-charge relay at a set time. So let's see what happens now. 30 ohms. Yep, that one has come on and this one should now go off. Right, so that's the way it's meant to be. So first of all, pre-charge on and negative on at the same time. Then main pause comes on. Then pre-charge goes off. This is just a quick update on the current situation and what we're going to do next. Now, if you've been watching what I've been up to, you'll be aware that the BMS has been wired in to the battery pack. This is the complete battery pack from here to here. Don't worry about these things, they're just old cell batteries are lying there. So the battery pack starts over there and ends over here, and that is completely connected together to give currently 350 volts or thereabouts through to here, but it's also connected into the BMS. And the great thing is we've managed to get the BMS to talk to my phone using this little adapter here. It's just a Bluetooth adapter that talks to is plugged into the OBDII port, and you can use software called LeafSpy to look at the BMS, and you can't control anything, but you can see what's going on. You can see the BMS is working, and you can see the voltage of all of the different cells. So that's fantastic. That's absolutely brilliant. It's one of the big steps that I was hoping to make, and we've managed to achieve that. The BMS is connected to all these battery modules and is showing up on LeafSpy, which is it's just an application you can get for checking on your Nissan Leaf. So the BMS is showing up in LeafSpy. I've got all the voltages showing up here, and I'm just going a bit closer. Voltages are all coming up, and it is actually trying to balance the pack. Very slowly, but at least it's trying. So that's working. The contactor block is working. I can switch on the contactors via that power switch there. The DC to DC converter is working. It sends through 14 volts, I think, through to the main battery, or the 12 volt battery. I know it sounds silly saying 12 volt battery when it gets 14 volts, but that's normal in cars. They all run around 14 volts. So that, when the second relay kicks in to turn off the pre-charge contactor, it also at the same time turns on the DC to DC converter to charge the battery. So that all happens basically when you flick that switch. What I plan to do is to take all of this stuff and put it in the car. I haven't been able to get the charger working. That's a bit of a disappointment. I've worked at it for quite a while now in conjunction with a chap on one of the web forums who has managed to get the Gen 2 charger working, and this is an Arduino Duo with his software on it, which I was trying to use to get the Gen 1 charger, which is the one I've got, trying to get it going, but I've failed, haven't been able to get that to work. So for now anyway, I'm just going to forget about this. I may end up having to go down the road of a Mitsubishi Outlander PHEV PHEV charger, which apparently has been cracked and we can use, or a Tesla Model 3 charger I believe we can use as well, but I'll worry about that later. For now I just want to get this stuff into the car because it's been sitting here for over a month, probably more like 2 months. It's been sitting here and it's time to move on. I can't spend the next 2 years trying to figure out how to get this charger working. So that's where we are. We have achieved a lot. We've got the battery pack wired together, we've got the BMS working, we've got the contactor block working, DC to DC converters working, the inverters working. The biggest part of the whole puzzle that's not working is the charger, and we can use any charger. That it doesn't have to be that particular one, so we'll worry about that later. So for now I need to get this stuff in the car. So anyway, hopefully that's been of interest to you. That battery box has been sitting there since last summer, so yeah, it's time to get moving. Anyway, thanks for watching and bye for now.